Good morning. This is Mr. Burns, CPDLF science instructor, bringing you your weekly chemistry launch. This is the first one for my class because we've had technical problems and I haven't been able to get into them before, so I apologize for that. I hope everything's going well this week in the course. If you have any problems with anything, as always, let me know and I'll get back with you and work right with you to get it solved. I want to see you be successful. As far as what you did last week, I like to review any sections that you might have had difficulty with last week. And the only one that I can see that is tough for many people is metric conversions. And the reason it's tough is because we're raised with the English system in this country, but science uses the metric system. The main thing you have to remember with this is that each type of unit, each measurement system in the metric system has a base unit. For instance, a meter is the base unit for measuring something. A gram is the base unit for weight, and liter is a base unit for volume. In the case of meters, every step, well, it all goes back to the prefix. Every step higher than that is 10 times the one that came before it, okay? So we have meters, we have decameters, we have kilometers, and it goes up from there. Each one is 10 times the one before it. And in the other direction, we have decimeters, then we have centimeters, then we have millimeters. Each one of those is 10 times less than the one that came before it. Now, I know sometimes it's confusing to work with that, but just like many other things in chemistry, the longer you work with it, the better and the easier it gets. So dive in, try to work with it, and I'll be glad to help you if you need anything. For this week, we have, well, you're going to learn about significant figures. The lesson's called Significant Figures to Show the Reliability of Data. That's 2.8. Using scientific notation with significant figures is 2.9. And by the way, there are specific rules that go with significant figures. And you might not think they're important, but in chemistry and physics especially, they're very important. If you don't use correct significant figures, your problem gets more and more wrong. For instance, you'll see many problems where one calculation leads to another. Well, if you didn't use significant figures, you just get more and more wrong. You get further and further away from your answer. So for accuracy purposes, it's extremely important that sig figs are used. There are different rules for multiplication and division, as well as addition and subtraction. So just work with them a while, get used to them. You're also going to take quiz 2. That's precision, significant figures, and scientific notation at 210. Measuring volume in the chemistry laboratory is 211. You have a project, practice in measuring metric volumes, 212. And measuring mass in the chemistry laboratory, 213. A lot of those are all new material. Just slowly work your way through it. Be sure to read the directions for each one. And the more you work with it, the better it will be. My reflection question for the week is, what is the difference between mass and weight? Send me the answer to that, and you'll get credit for attending this launch session. So, again, if you need anything, let me know. I want to see you be successful. So have a great week and a great day, and I'm sure we'll be talking again. Bye now.